Hey y'all, in this video we're going to look at triangle congruencies again, and specifically we're going to look at the special case of right triangles and to see if there is an additional triangle congruency that only relates to them. So I've started off, we have a line segment AB, which is going to be a side of our right triangle, an angle B, which is going to be an angle of the right triangle, but not the right angle, okay? So it's acute. And I want to know how many triangles can we construct with just these two pieces. Now, if I can construct a unique triangle, that's super special, but I can't because I really have two options for what angle could be the right angle. One option is that angle A is the right angle, and if this is the case, then I just have to construct the perpendicular line to AB that goes through point A, and it's going to be like somewhere over here-ish, right? And it's going to create that right triangle. And the other option I have is to make the unlettered angle be the right angle, which means I need to construct the line that is perpendicular to this ray that goes through point A. So I'm looking at this line here, right? Or this line segment here. And this should be familiar to you because it's one of our main constructions. Mainly, it's the shortest distance construction, right? So if I put my compass point at A and I want to construct that shortest distance, then I'm going to notice something, right? And it should remind me of one of the other triangle congruencies that we were looking for. Okay, so if you remember, we had something to explore called angle side side, where you're given an angle and two consecutive sides of the triangle. And we discovered that that wasn't going to be a triangle congruency because if my compass radius is that length of that second side, I need to be able to draw a unique triangle from that radius. And when I swing the arc, I have two places where that third vertex can be, and that gives me two possible triangles. So if I know I have an angle, a side, and a side congruent on two separate triangles, I know those triangles can't be congruent because one of them might be going, the one that goes to that point, and one of them might be going to that point. But if I know that second side is specifically the shortest distance from that point to that ray, then I have a unique triangle that I could construct, right? Because there is only one shortest distance, and that shortest distance is the perpendicular distance. So angle side side works, but only if this distance, the second side, is the shortest distance, and this is a right triangle. We don't call it angle side side because that's too generic. This is specifically something that only works for right triangles. And so if I think about what the sides are, well, this side we call the hypotenuse, right? And this shortest distance, we don't call it a shortest distance, we call it a leg. If I know that I have two right triangles and they have congruent hypotenuses and congruent legs, I can say those two triangles are congruent. I don't have to do anything else. So we call this specifically the hypotenuse-leg conjecture. It is an unnumbered conjecture, kind of like an extra. So if the hypotenuse and leg of a right triangle are congruent to the hypotenuse and leg of another triangle, then the two right triangles are congruent. And remember, only works for right triangles